Let's try another one. Let's look at this next one. Again, let's break this up into two different pieces. Let's deal with the first graph first, which is this 4x minus 3y is less than or equal to 12. And I'm going to do a mock-up here below this time because I'm running out of space. So let's figure out what this line would look like. Let's put it in slope-intercept form. So we'll get y by itself by subtracting 4x from both sides. That'll get us a negative 3y is less than or equal to. Let's still write the negative 4x first. And then I'll write the 12, the positive 12 second. Then the last step is dividing everything on both sides by a negative 3. Again, be careful. That's going to flip the direction of the inequality. So it will become y is now greater than or equal to. Let's see what we've got here. We have, let's see, a negative 4 over negative 3, which is actually going to become a positive 4/3 x. We also have, let's see, a positive 12 divided by a negative 3, which is going to be a negative 4. So how would this guy get graphed? Well, you'd start with your y-intercept, the b, which is at negative 4, which is down on the y-axis at negative 4. So I'll start there on both of the graphs. Then we had a slope of 4/3. It's positive. Remember, it's going to be your rise over your run. Because it's positive, we're going to go up 4 and right 3. So we'll go rise will be up 4. So we'll do that. Up 4 and over 3. 1, 2, 3, 4. And then over 1, 2, 3. Do that on the top graph as well. 1, 2, 3, 4. 1, 2, 3 over. Now, be careful before you draw your graph. What kind of graph is it? Remember, the greater than or equal to means that it's going to be a solid graph, not a dotted. So I can go ahead and draw in a solid line. Okay, last part. Which side of my graph do I shade? Well, you need to pick a point to test. Let's test 0, 0 as always. It's not on a line, so we can use it. Now, you can plug it into your version of the line that you've already solved for, or you can plug it into the original graph that we had. The 4x minus 3y is less than or equal to 12. I personally like plugging it into the original because I haven't messed with that. So I have less chances of making a mistake. So I'm going to plug it into the original. 0 for x and 0 for y. Well, notice then you get 4 times 0, which is 0. 3 times 0, which is 0. 0 minus 0 is still 0. So this entire left-hand side here, all this stuff, just turns into a 0. So you have, what does this end up meaning then? So you get 0 on the left-hand side, and then we still have the less than or equal to 12 on the other side. Is 0 less than or equal to 12? Yes, it is. So 0, 0 works in this case. So on my mock-up only here, I'm going to go and shade that side because 0, 0 worked that side of my line. So let's see, I'm going to do it in blue just to be consistent. Actually, my graph was red, so let's do red. So let's draw that side of our, shade that side of our line because 0, 0 worked. Okay. Now we have to graph our other graph. Let's see what our second graph was. Our second graph was y is less than x squared. Well, that's just a parabola with a center at 0, 0 with no stretch, just pointing upwards. Be careful, though, is that because it's less than and not less than or equal to, it will be a dotted parabola. So I'm going to draw a dotted parabola. Again, it does not have to be perfect. All right. Problem. I cannot use 0, 0 this time to test for the parabola only. Why can I not use 0, 0? It's because the graph actually goes through 0, 0, so I need to pick something else. I'm going to pick anything I want, but I'm going to pick this point up here. I'm going to pick 0, 2 to test. So that means I'm plugging in 0 for x and 2 for y. Well, 0 squared on the right-hand side will be 0. And 2 will be on the other side. Is 2 less than or equal to 0? Or sorry, is 2 less than 0? Absolutely not. So what does this mean? It means that for the parabola, my new point 0, 2 does not work, which means I will not shade the inside of the parabola. I will shade where the 0, 2 is. I'm going to shade outside of it where the point isn't. I'm going to shade where the point isn't because where the point was, it didn't work. So that means I'm going to shade everything outside of the parabola. Okay. So now the question is, what do I need to include in my final answer? Well, remember, my final answer should only see the overlap part. Well, notice the overlap part is all the stuff in between the two graphs that got shaded both red and blue. So I can go back to my final graph, which is above, and I'm only going to shade the stuff that's in between. All this stuff. Again, it doesn't have to be perfect. I'm trying to get everything I can, though. But that's what needs to be shading, is everything in between the parabola and the line. And that's it. That's our actual final graph, is the one where we're only shading the overlap. Last one.